Hi, Lamai. Yesterday, actually 21st, was like most of the forgetful day because signal level was extremely low. I couldn't really do the class, technically do. I did, but not like in the proper way. So by the way, don't worry because if something happened, this is the first time in my online class history it happened. No router was responding. There was a massive network jam, almost like lasted 12 hours. In the morning, around 8 o'clock, only got finished up for some weird reason. No router was responding. By the way, mm, I am going to make up video for the losses. Like, consider this one as you were in the class, write your note, because I'm going to give you a writing note, write that, and get ready for the game. Like, we have to do like how to take readings. Firstly, let me show you how to make the reading here. Have a good look at here. Okay, you can hold the thing using external jaws. These two are said to be external jaws, but unfortunately, in the tube, it's been printed mistakenly as the internal jaw, external jaws, because you take the reading of external diameter, right? And whenever you want to take like a internal reading, like so here, if I want to measure the internal diameter, I have to say internal jaws like this, it, and but there is here screw lock screw using the lock screw and lock this and read. But here this is just a model. I even gave you the model because to understand this concept, because this concept is something really peculiar for many students. The last one, let me show the last one. Depth. How can I measure the depth of this one? See, there is a hole, but using any other ruler, I can't take it. But using this one, putting this depth gauge down and until it took contact with this bottom surface, I can move it like this. So see, now there is a reading over here. How to hold it firmly, and get the reading. Now the biggest problem is how to get these readings. You know, you can take external reading, outer reading, and depth measurements all three together. But there is a big problem. What? How to read? I taught you this regarding this one in the very last week, but very lightly. So today I am going to show you how to make it happen. The first thing is how to consider the main scale. In the main scale, any. So I'm going to shorten this one like this. Any line, any x line of the main scale, x can be 1, 2, 3, 0 even. If it is just past this one, it can also be for an error or something. First line, 0th line, first line, 100th line, like that. For an example, I take it like 18th line. So what is the least count here? Least count is LC, I will write it bigger. LC least count is 1 millimeter. Okay. So what is the main scale reading is going to be now? Main scale reading is 18 into 1 millimeter. So it is 18 millimeter. I leave it. Now, how to detect that? So have a good look at, you might not see the numbers clearly. Okay, by the way, you have to take this 0 line of the vernier. bottom line is 0 line vernier. For your convenience, I am taking the 10th line. It just got past the 10th line. See, you can see that clearly. Your reading is indicated by the 0 line of the vernier scale. When the 0 line of the vernier scale got past some point, that point is the one you are supposed to have like the main scale reading. This is the 0 line of the vernier scale. It got past. Once the 0 line of the vernier scale got past any line in the main scale, that is the main scale reading. So that's done. Then how to take vernier scale reading? Any line in this vernier scale, any line in the vernier scale, when it is exactly coincide with, consider this one as the main scale and this one as the vernier scale, when it is exactly coincide with each other, so regardless of what is the main scale line, you have to take the number of the vernier scale line. So here I am just considering of any y line of, I don't want to worry about that, any y line of the main scale is just exactly coinciding with my vernier scale reading, nth line in the vernier scale. So here I am going to consider this my nth line as sixth line. I am considering about the regular vernier scale, not the extended vernier scale like this. This is called the extended one. I will teach you how to read extended one, how to make any other vernier scale, likes of the 1 minute please. Where is that one? Where did I keep? Right. This one is also a very good vernier scale. So this whole thing is I will teach you this in like mostly about 1 year and 2 months later, because in the optics, in degrees, up to 360 degrees, but there is a vernier scale. So in the vernier scale, it is about what? It is marked in minutes. Sorry, yeah, minutes. You know, degree, minutes and seconds, that's how they divide. So minute means 1/60 degrees. You can measure it up to minutes, right? So it is still a vernier scale, but not a linear. It's a circular vernier scale. Like that, you can create any vernier scale. I'll show you many examples. There are vernier scales made out of like, not like the standard one. In the standard one, we have only what? 10 divisions in the vernier scale coincide with 9 divisions of the main scale. That is the standard one. The one I sent you is the what is called extended vernier caliper. In your school labs, also you have the extended vernier caliper because the extended vernier calipers are more precise. And here also I have to tell you one more thing, one more important thing. In this extended vernier, in school ones, normally even better than my one, some schools contain 0.02 millimeter accuracy. I will teach all of these today. First thing you have to understand is, any line of the main scale got passed by the 0th line of the main scale, vernier scale, is the reading. The reading, what? The reading. The reading. Okay. Okay. Now, any line of the main vernier scale is exactly coincide with any line of the main scale. It cannot be like this, it cannot be like this. It should be exactly locating like this. See, perfectly fitting. So that line of the nth line of the vernier scale is considered like the vernier scale reading. So I taught you how to read the vernier scale. Vernier scale reading. How to make that happen? There's only one way. N times least count. Right. N is what? 6. Least count is 0.1 millimeter. So the Vernier scale reading is going to be 0.6 millimeter. Understand? Now you have to get the Vernier caliper reading. Let me give you Vernier caliper reading is main scale reading plus Vernier scale reading together. What is my main scale reading? It is 18 millimeter plus 0.6 millimeter. So my answer is going to be 18.6 millimeter. Can you understand? Right. Now I want to explain something about zero error. Zero error is a kind of systematic error. Systematic error means it repeats exactly how it is. Hi, මම ඔයාලට මේ පොඩි demonstration එකක් එක්කම කරලා දෙන්නම්. Give me a 1 minute. I will come up with all the equipment it needs. Okay, Ramay. Have a good look at this one. A brick, right? I am going to make the measurement of the brick of the thickness. Here, it is somewhere like exactly 9 centimeters. Now I'm going to place this brick. Stand on it. Right. Exactly on the beginning of what point here. So I am going to stuff like what this one exactly on the ground, not on the top of the brick, and mark my scale. Mark my scale for you to understand where. Exactly on the ground. So, merely considering about my height. මම මෙතන මාක් කරන්න 79 80 81 82 83 84 85 86 87 88 89 90 91. Right. I don't need anything longer than that. Right. මොකද මට මේකේ උඩ පිට ගත්තත් එච්චර උසට යන්න බෑ. Right. Let me show you one thing. Right. 90 degree තියෙන හරි gadget එකක් ඕන වෙනවා. මම මේක හැදුවේ ඇත්තටම මේ වෙන වැඩකට. මම දැන් පාවිච්චි කරන්නේ අමුතුම වැඩකට. I will stay here on exactly 90 degrees. So it is coinciding with this third line. And you can, if you can remember, I started with 179 179. So the second line means exactly 181 centimeter. Right. Now the biggest problem for me is now I told you earlier there is a brick now. Now I am going to stand on the brick while holding this thing. It is somewhere nearly this one. Nearly this one. මේක හරියට තනි කෙලින් ගහපු නැති හින්දා ඉතින් හරියටම ආව කියන්න බෑ. So 82, 83, 84, 85, 86, 88, 89, 90 හරි ඇවිල්ලා. Right. This is 190 centimeters now. Oh my god. I feel like I'm 6 foot and 10 tall. Actually no. I'm like 5'11", half and something. So now I feel this being added up. If something is being added up, I have to remove it. Next, I have to remove it. Now what can I do? Now my reading, actual reading is what? Actual reading is the reading minus my error. Okay, this is a positive error. So what is my actual reading is going to be? 190 minus 9. So my actual reading will come up like 181 centimeter again. Can you understand? If I was standing on the brick, okay. Let me do one thing again. Now I am going to calibrate the same stuff using this one. Here in this one, using this one. Okay, right. I'm now starting this bit. Now I'm keeping it on the top of the surface of stone. Sorry, brick. It is like 172 here. I will mark that in the other side. That's how we take a battle on. It is going to be 172 now. Okay, then we have a centimeter of the highest figure. What up there? Every grand or there? 79, 71, 70, 69, 68, 67. All in there. This is what my reading I am getting when I on the ground, but the reading has started from that brick. පොඩි අවුලක් තියෙනවනේ. ඒ කියන්නේ මම මෙහෙම ground එකේ. But the reading starts with 0 on top of this 9 centimeter rock. But I am on ground. So this is my reading. Now, new reading, my new reading. But the 0 is just above my feet. So there is an error. There is an error. Already an error. But the reading started somewhere. The actual location is just below that. So it is a negative error. Can you understand? It is a negative error. මොකද reading එක පටන් ගන්න තැනට වඩා පල්ලෙහායින් තමයි පටන් අරන් තියෙන්නේ. So I have to, so the error is at 9 centimeter. My new reading is 172 centimeters. මට මාන කොටෙක් වගේ වෙන්න ගන්නවා. ඒ කියන්නේ 5යි 7ක විතර ෆීලිං එකක් එනවා. පට අවුල් එතකොට. අවුල්ලා. දැන් මම මොකද කරන්නේ? දාගෙන හොයනවා මට මොකද්ද උනේ කියලා. වෙන්න බෑ. දැන් මම හොයනකොට බලද්දි රීඩින් එක පටන් ගන්න තියෙන්නේ වැරදි තැනින්. So what can I do now? Now I have the option of rechanging it. What is my equation? Actual reading equals to reading minus error. Okay, the same thing. Actual reading is, what is my reading? 172 minus what? Again minus what? Here the difference 9 centimeter. Minus and minus become plus. 172 plus 9. Again I am getting 181. Oh, big relief. Big relief. හරි. ඔක තේරුම් නැත්නම් මම තව වෙන විදියකට කියලා දෙන්නම්. මොකද ඔයාලට මගේ කකුල තියෙන දැන පේන්නේ නැහැ. Okay. Pause the video and copy this thing if you want. So now let me explain you with pulling your scale. Pulling your scale. This is ground. This is that block, so-called block. There is a one occasion, the meter reading is calibrated like this, starting the 0 on the ground, no problem. Now you place a man, there is a positive error here, and you place a man on top of it like this. Okay, the reading. You get the reading. Now, there is the reading. This is what your actual reading it should be. But unfortunately, your whole reading is this whole thing together. So the reading include what? Actual reading plus this error. So when you rearrange, actual reading equals to what? Reading minus error. So you can subtract and get it. The second scenario is, now the second case scenario is the scale is already there, but the scale starts from the block. But the man is standing on the ground now. This is what you're reading. This is what the actual reading it should be. This is where the error. So it is a negative value because the reading should be started even below that. So what can you do now? Now the reading, actual reading, is what? Reading plus my error. So the reading is what? Can you understand? Actual reading is reading plus error. So this thing you have to understand. Copy this diagram. It is better for you to copy this diagram. Watch this video, this part one more time, because most of the students, even in the last night, under really calamity condition. They'll just give me the answers like, sir, this is what, this is that thing. I will upload that video too. ඒවට බලාගන්න පුළුවන්. සමහරව ලස්සනට answers ටික දැම්මා. නමුත් මම දන්නවනේ හැමෝටම ඒ වගේ තේරෙන්නේ නැහැයි කියන දේ. You know, everybody can't understand the same manner. So I have to give them my support as well. Now it is the time. Okay. So you got some idea about this one. Now I am going to my regular, the usual writing board to explain you everything, because I have explained this scenario exactly. Now the very last thing I want to do is for Vernier thingy, you have to shut these two up, close these two jaws, and to see whether the zero line of the main scale is exactly coincide with zero line of the main scale. Okay. If it's exactly fitting like this way, you don't want to worry about. But if the thing is Vernier scale is slided forward, it's supposed to be a what? Positive error. If it is gone backward, it's supposed to be a negative error. I will explain you all these things the other board, my digital board. Okay.
ඉතින් ළමයි, now I'm going to continue with my board. You will actually thank sir every day. Please have a network problem. We can get a much better video in the next day. Actually, I can, because the reason is so no interruption, no need to explain the same thing back and back. So I can continue and concentrate on my mind. Don't worry, the class is going to be the live class as well. It's not going to be a full recording thing. I'm just kidding you. But even the worst scenario like this happen, you will be nothing to worry about, because it is me. So now, right, the next thing, zero error of Vernier Caliper. Zero error of Vernier Caliper. Vernier Caliper. Right. Zero error of Vernier Caliper. Let's see how to do it. Right. Before doing that, I wanted to teach you how to make that reading and what is Vernier scale again for one last time. Even though we learned in the last week, I know that there was at that day I had really super strong signal, but some of you students got some kind of signal lagging and other things, and you were not available. And even for the students who remained in there, they happen to be not understanding this one properly, because but I included this all details in your textbook that I provided to you. So this is actually I abstracted from that theory note I provided you. It's a physical one. See? Vernier scale thingy. I just cut these things from there and have a good look at in the Vernier scale. So I'm going to explain you that. If you study my tudes, you can understand everything, because there are some other students, they finish the theory tudes thingy before starting the class even. This is, I only take like 9 millimeter of the main scale, because this is like your foot ruler. In the foot ruler, you have like separations of 1 millimeter, and you select 9 millimeters of that, and you divide that into what? How many pieces? 10 pieces, right? This is how you make the Vernier scale. Vernier scale. How to make the Vernier scale? Select any n number. This is the n number. N is 9 for this. From here, and you divide that into n plus 1 division. One more division. Always remember, in Vernier scale, what there is a n plus 1. N means the number of lines in the main scale. You have one more than that. That's the principle of the vernier. It's not very big deal. If the number is 45, just imagine, right? What is the vernier scale number? This is the main scale number. So what is the vernier scale number? Then it should definitely be 45 plus 1. That means 46. For an example, it can be any value, any scale. You would include what? One more reading. You get the same distance. Let me explain you that again. In 2024, students, I just explained that in some exclusive manner. I am going to explain the same thing in the same exact way. Yeah, you have a distance of සමහරුන්ට 3D understanding problems තියෙනවා. Spatial recognition. It is also an IQ of person. IQ එක කියද්දී spatial recognition කියන කතන්දරෙත් අයිති. සමහරුන්ට හොඳ බුද්ධිමත් ළමයි. but එයාලගේ IQ level එකේ spatial recognition පැත්ත නැහැ. ඉතින් එයාලට අවුලක් වෙනවනේ. It's like 100 meter. Right. There are two guys. One is a tall dude. Very tall dude. And he has his span of leg is like long stride. Robin long stride. Ne the Robin Hood ගෙනම it's like X. Okay. And there's a short dude. He has strides that of what? Y. Okay. He always makes distances of X similar to X. Now see. Similar distancing. So he has to keep what? N times, what is that? The reading always X, 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 and X. N times X. He has to place what? How many? X type of. No. I made a mistake. කොට අඩි තියාගෙන යන්නේ මෑන්. Right. Let me see. Now you may have an idea. All the time he keep what? Y. Y, 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 Y. I don't know why. So what is it? Capital N times Y. Can you understand? Here they have keep like two different scales. The length I take it like L. L equals to NX, equation number 1. The other one is L, the same L equals to capital N times Y. Equation number 2. You can equal these two. Equation number 1 into equation number 2. You can equal because both is L covered the same distance. Nx equals to capital N times 1. This is what the very basic concept of vernier scale. Can you understand? You took like a long reading from here. You keep it like what? How's it now? You read like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. N times of X being applied. Here like of what? N times of Y is being applied to here. But the final destination is the same. So you can equal these two. I think you get some idea. here it is always the same distance of 9 millimeter being divided into 10 parts. So this one has a long stride and this one has a short stride like person walking along. Now it is like if 9 millimeter is divided into 10 equal parts, the length of the part would be what? 1 over 9 over 10 millimeter, which means 0.9 millimeter. Okay. You had what? 9 millimeters. You divide that into what? How many parts? 10 such parts. This is from the main scale. This scale is known as main scale, where you took 9 millimeters. The part divided into 10 such parts is known as vernier scale. Okay. Because why? You divided 9 millimeters. You divided 9 millimeters to 10 equal parts. So then your least count of the vernier scale. Least count කියන්නේ ළමයි මෙන්න මේ ඉරි දෙකක් අතර තියෙන gap එක. Millimeter 9ක් 10කට බෙදලානේ ගත්තේ. So it is like 0.9 millimeter. This thing you have to understand. If you couldn't understand in the very last week. Now I'm repeating that process again. Now here it is that, so 0 to 0 tally, 10th line is 9th line is to 10 lines tally. That means with no zero error. I will tell you what is zero error later. Now what I'm going to do is I can slide this along. See, ඔයාලට vernier එක ඇවිල්ලානේ තියෙන්නේ. බලන්න ඕක slide කරන්න පුළුවන්. දෙපැත්තටම කරන්න බෑ මොකද මේකේ touch එක. You can slide it along this side. See, until you get the reading. When you are sliding, you can see only with one line it will get coincided with. See, the 0 of this one has just passed. I just explained that in even. So the 5th is the reading of the main scale. What is the vernier scale reading? Not first one tallying, not the third one tallying, not the 4th, 5th, 6th. පොඩ්ඩක් හරියට පැනලා නැහැ. But second line is ideally tally. හරි නේද? කොහොම අපි tally කරන්නත් පුළුවන් නේ. tally කරන scene එක තේරුම් නැති අයට. හරි, don't worry. I'll come back to this part again. The importance is you can slide along. So when you are sliding, when you keep like this thing along, always it makes what difference of 0.1 millimeter between, because this line is separation between one line in the main scale is 1 millimeter. Separation between one line in the vernier scale is 0.9 millimeter. So there is a gap of 0.1 millimeter. Okay, that gap will be representing all the time. So the shortest possible distance that you can measure is now altered. It is not 1 millimeter any long. It is what? 1 millimeter minus 0.9 millimeter. That means it is 0.1 millimeter is the new least count. Okay. This idea I had to convey to you. So the least count of the vernier scale is too big. Okay. The least count of the vernier scale is the least count of the caliper is known as the vernier constant divided by the difference between one main scale division. See, difference between one main scale division and one vernier scale division. Okay. What is that? Vernier scale is what? 1 MSD, Mahendra Singh Dhoni, minus 1 vernier scale division. Here, what is the one? 1 millimeter for our regular vernier. Here, what is it? 0.9 millimeter. So, what is the least count? 0.1 millimeter. Understand that? Okay, there is a common formula for here. You can just understand it from here, the MSD, and you can get it. I have explained these things earlier. Hari. මම අර තව වීඩියෝ එකක් 40 minute විතර වීඩියෝ එකක් දැම්ම නේද කියලා. ස්පෙෂලි හදපු එකක්. ඒක 24 batch එකේ ළමයින්ට හැදුවේ. ඔයාලටත් දැම්මා බැලුවා නම් ඒක තේරෙයි. ස්ලයිඩ් කර බලද්දී කොහොමද ඒක gap එක එහා මෙහා වෙන්නේ in detail. You don't want to understand the vernier scale in detail. I applied that video only for those who really curious. අම්බාන curious side විතරයි. ඇත්තටම මේ දේවල් එහෙම deeply දැනගන්න ඕනේ. Okay. Find the least count of the following scale composed of main scale and vernier scale in a manner as represented in the figure. Okay, let's see. In this figure, what is it? 0 of the main scale is touched with this one. 9 millimeter is divided into 10. Length of 1 unit of the main scale. Now you will understand everything. 1 millimeter. You can see that from here. එක දෙක තුන හතර කියලා 10කට බෙදලා තියෙනවා මිලිමීටර්ස් එන එක ગેප් එකක් තමයි please count කියන්නේ. The length of unit of vernier scale is what? You have to divide 9 millimeter into 10 and get that because it is 0.9 millimeter. It is not visible on here, so you have to do what? You have to divide that so that make it in and this is 0.9. No, you can't see. The only thing you can see is 9 millimeter is divided into 10 divisions. So you have to show that how to obtain. What is the least count? Least count means 1 millimeter minus 0.9 millimeter, and you will get least count of the vernier scale as 0.1 millimeter. This is really simple thing. Really simple scenario. Okay, Lamai. Now the next one is an extended vernier caliper like the one I provided to you. පොඩ්ඩක් මේක extend කරලා තියෙනවා. Let me show you that clearly. මම ඔයාලට කිව්වේ මේ වගේම එකක්. මේ තියෙන extended vernier caliper. Have a good look at 0 line of the vernier is in contact with this one. One main scale is graduation of 0.95 millimeter. Which line it is coinciding with now? With the 19th line. 19 is divided into 10. No, it is not 10. 10 such with divisions, but the smallest division is not 10. So, what is it? How many parts? 10. In each bigger line, there is another line. That means it's been separated. Any bigger line is separated into 2 parts. In there are 2 lines. So 6 to 7. 6 to 7. How many lines? 1, 2. All the time there are 2. 2 times 10 is 20. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. හරිද? කොහොමද තේරෙන්නේ නැත්නම් ඉතින් ඒ ලෙවල් ගන්න එක ඇත්තට සුදුසු නැහැ. හරි? මෙන්න main scale මෙන්න vernier scale අපිට slide කර කර යන්න පුළුවන්. Length of 1 unit of the main scale is as usual 1 millimeter. No problem with that. Length of 1 unit of vernier scale is a different case now. Why? It is what 19 millimeter was there. You have divided that to 20 parts. Millimeter 19 අරගෙන යාව කියන්නේ 20කට බෙදලා. දෙකේව 10ක්. So it is this fraction you can leave it like as a fraction, or you can leave it like 1.9. So 1.1 0.19 millimeter. Oh no 20. ඒක කරදරයි ඔක fraction එකක් විදිහට තිබ්බොත් please. Least count. What is the least count? Okay. 1 minus 19 over 20. Then you have to cross multiply. Here the 20 minus 19 over 20. So it is like what? 1 over 20. So that means 0.05 millimeter is the least count. හරිද? මේ දෙක අතර graduation එක තමයි අතර 0.95 කියලා දෙනවා තියෙන්නේ. හරිද? ඇයි මේක බෙදපුවාම කීයද මෙතන? 19 දෙකෙන් බෙදපුවාම කීයද 9.5 නේ. එක 10න් බෙදපුවාම 0.95. හරිද? ඕනනම් ඒ විදිහටම අඩු කර හැකි. 1 minus 0.95. Still you get 0.05 millimeter as the least count of the vernier caliper. If you don't understand, just repeat and watch this. You have the freedom of watching that way. Copy කරන්න මේ ටික හරි ගියේ නැත්නම්. Okay, now consider a main scale composed of 1 millimeter unit where 49 of these units are divided into 50 units of the vernier scale. මේවා මතක තියාගන්න ඕනේ නා කියන්නේ කටපාඩමින් නෙමෙයි හදලා. තේරුම් ගන්න. Consider a main scale composed of 1 millimeter units and where 49 of these. The length of one main unit of the main scale is 1 millimeter. It's given length of 1 unit of vernier scale is what? Oh yeah, you divide what 49 such thing into 50. So what is it going to be? Just leave it like a fraction. Or you can get it like what? 0.98 millimeter. Fraction. So what is the least count? Least count is what? 1 minus 0.98 is like 0.02 millimeter. Mostly you have a chance to get this in your school as this vernier caliper. මේක තමයි ගොඩාක් වෙලාවට ස්කූල් එකක තියෙන්නේ. අපිට තිබුණේ නම් ඔක තමයි. මම උගන්නත් තිබුණේ ස්කූල් එකේ. Try to draw this space at your homework. Was that easy? මේක ගෙදරදී ඊට වඩා කරලා බලන්නලු. කරන්න කම්මැලි වෙන්නේ නැතුව කරන්න. එනෙත් මම එහෙම මට කරලා ඉවුවා උඹ. උඹලම කියා. හරි අමාරු විශ්වය දෙයියා. කියන්නේ වෙලාවක් තියෙනවා නම් කරේ අත්‍යවශ්‍ය වැඩක් නෙමෙයි. කැලි පොඩි නමයක් අරගෙන ඕක අපිටම 50කට බෙදන්න ඕනේ. ලේසි වැඩක් නේ. 50 යන වැඩක් නිකන් කරලා නිකන් අර පාට් නිකන් අයියා එකක් ගන්න කරලා බලන්න කියලා කිව්වා. අත්‍යවශ්‍ය නැහැ. Consider a main scale consists of 1 millimeter unit. Oh yeah, this 1 millimeter. Oh yeah. Length of 1 unit of vernier scale is calling me out now. Okay, Rama, it is like the length of one main scale is 1 millimeter. The length of unit in the vernier scale is what? 99 over 100. So 0.99. So what is it? 1 minus 0.99 is 0.01. මේකත් කරලා බලන්න හම්බ වෙන්නේ නැහැ මේ දෙකම ඔයාලා අපි කරලාවත් කියලා නවත්තනවා. ඕකේ මම පොඩි අයිඩියා එකක් දෙන්න හදන්නේ. ඇයි දන්නවද? පොඩි අයිඩියා එකක් දෙන්න හදන්නේ. කරලා බලන්නකෝ. කරලා බලලම මට කියන්න. පොඩි try එකක් දෙන්න. වරදක් නැහැ. Try it. You won't be success. Even I won't be. But give a try. In the next week, I will explain you why it is. So please try. හරියන්නේ නැහැ මම දන්නවා. But try. In the next week, to learn micrometer screw gauge, you will get a clear idea. Oh my God, sir, that's really horrible. So you will understand why. Please do this, and you will definitely understand why there should be a micrometer screw gauge. හරි නේද? ඔන්න බේසික් කතන්දරේ ඉවරයි. හරි? Calculations more here. Right. Let's go for here. Okay, Lama, I forgot to take, and I was about to do this thing in the last week even. The following calipers have no zero error. That means you don't want to worry about zero error. Determine the actual reading of the caliper. Okay, I have to give you a proper practice for how to read. Now have a good look at. I told you that once the zero line got past any line in the main scale, that's the reading. So you can clearly see it is not the third line, it's the second line. That is 2 from the main scale reading. Now your biggest problem is to tally which line is coinciding with any line of the main scale. මම ඒකටත් ඊයේ පොඩි අයිඩියා එකක් දුන්නා. මම ඒක අදත් කියන්නම්කෝ. ඊයේ ක්ලාස් එකේ හිටුනමයි දන්නවා දුන්න අයිඩියා එක මොකක්ද කියලා. I told you if the line, any line x is gone past by any line of the zero. හරියටම මැද්ද කියන්නේ මෙතනනේ. يعني 10යි නේ ළමයි කියන්නේ. There are how many parts? 10 parts. 1, 2, 3, 4, 5. It should be the fifth line නේ. හරි. මෙන්න මේක තමයි fifth line එක. හරි. 5 කියන්නේ මෙන්න මෙහෙට සෙට් වුණොත් 5 වලට සෙට් වෙනවා. ඒ කියන්නේ අපි Vernier එකෙන් හොයන්නේ let me explain you what is Vernier scale, purpose of Vernier scale. It has gone past somewhere. No? This dial has gone past somewhere from this reading. මෙන්න මෙතන ඉඳන් මෙතෙන්ට තියෙන gap එක ඔයාලා මේක දිහා බලලා කියන්න බෑනේ කොච්චරක්ද කියලා. It is like 2 point what? Approximately like 7, 8, 9. What is it? Whether 7, whether 8, whether 9. You can't just predict. That one is found by the Vernier scale. ඔන්න ඔච්චරයි ඔකේ තියෙන සෙල්ලම. මහ දෙයක් නෙමෙයි. main scale එකෙන් direct ම ගත්තා. හරි. මෙන්න මෙතන ඉඳන් මෙතන තියෙන gap එක තියෙනවනේ ළමයි. There is a gap between these two lines now. That reading is read by Vernier reading. Can you understand? Very simple it is. Now, if you take this bigger line, like this is like what? Second line. This is the other line, third line. If it is exactly line in between, it should be, you check somewhere around what? 4 to 6 line වල check කරන්න. If it is somewhere here, what is it? නිකන් හරියට දෙක තුන වගේනේ. You should check the second or third line of the second to fourth line of the දෙකේ ඉඳන් හතර වගේ වෙනකම් බලන්න ඕනේ Vernier එකේ. If it is this end, අන්තිම හරිය නම් 7 ඉඳන් 9 වගේ line එකක් බලන්න ඕනේ කොයි හරියද තියෙන්නේ කියලා. ඉතින් මේ line 10ම මේකද කොහොම බල හිටියොත් ඉස්සු හැදෙයි. බලන්න බෑ. ඉතින් අපේ අයිඩියා එක තියෙන්න ඕනේ යා ගොඩක් ඈතට ගිහිල්ලා නම් ඒ කියන්නේ මේ හරිය වගේ නම් 7 ඉඳන් 9ට, මැද වගේ නම් 4 ඉඳන් 6ට, මුල වගේ නම් 2 ඉඳන් 4ට. If that is like rotating exactly somewhere like middle, you may try with like the 4th to 6th. If it is early stuff, you should check with the 2nd to 4th. If it is in the very late, so you may check with the 7 to 9. Very simple understanding ළමයි. nothing else. හරි මේක නිකන් හරියට ටිකක් ඈතනේ දෙවෙනි line තුන්වෙනි line එකට කිට්ටු. It is more closer to the third line than the second line. This is somewhere here now. This is more closer to what? Third line. That means මෙයාගේ බලන්න ඕනේ third line එකේ කිට්ටුවෙන් තියෙන්නේ 7 8 9 නේ. මේ මම මුලින් නම් යන්නම්. 0 is not obviously tallying. First line is not, second line is not, third line is not, fourth line is not, sixth line is not, seventh line is not. Sorry, sixth line is not, seventh line is not, ninth line is not, 10th line is not, eighth line. මේක බලනවා නම් මම බලන්නේ කොහොමද මම කියවනේ අග තියෙනවා නම් 7 8 9 බලන්න කියලා 7 8 හරියටම සෙට් වෙනවා. ඉතින් ඒක ඔන්න ඕකත් මම ඊයේ කියලා දුන්නා. අද ඊට වඩා හොඳට තේරෙන්නේ නැති කියලා හිතනවා. So what is the reading? So reading is what? Main scale plus Vernier scale. Main scale එකේ 2 mm, Vernier scale එකේ හොයන්න අපිට ක්‍රමයක් තියෙනවානේ. මම කියන්නේ Vernier scale reading is what? n times of least count. N is what? 8th line. Least count is like 0.1 millimeter. So it is like 2 plus 0.8. So it is like 2.8. Sorry, this is that's given in centimeters, please. 2.8 millimeter in terms of centimeters, 0.28 centimeter. ඒක හොඳටම කල්පනා කරන්න මේක දින තියෙන centimeters. ගත්ත විදිය තේරුම් නැත්නම් පෝස් කරලා එකපාරක් බලන්න. හරි. Now the next one. දැන් ඔයාලට physical live class එකේ නම් මම අහනවා. දැන් අහන්න විදියක් නැහැ. මේක record යන්නේ complete. Okay. Which is the line gone past? The fifth line. Fifth is the main scale. Main scale. Now I have to find out this gap නේ මට එහෙම බලලා කියන්න බෑනේ. මේක හරියටම 7. එහෙම කියන්න බෑ. So you can see one thing obviously This is far from the middle point. That should be like 7 to 9 range. So I should check that again in the 7 to 9 range. Oh, you will see that this is like what? 5th, 6th, 7th. Exactly coinciding with the 7th, 8th, 9th, 10th. It is 7th line. මං කිව්වට මන්ත්‍රය පාවිච්චි කරන්න. එතකොට හරි ලේසි උත්තරේ හොයාගන්න. This one is what? 8. Right, okay. It is like a mantra. You can chant this mantra and get this. Reading is what? Main scale reading is the 5th. 5 plus what? Sorry, this is 7. 7. That's 7. 7 times 0.1. So you get like 5.07. So 5.7 millimeter. You have to plot the reading in centimeters. 0.57 centimeter. හරිනේ unit conversion වලට කරනවා තියෙන කාලයකට කලින්. Let me explain you this one too. Now here 0 is we can't exactly say it is like 10. හරි මම මෙයාව මට හරියටම උඩ තියනවා කියලා යන්න බෑනේ. So I take this one as what is it? 8. මට සැක සහිත පහු වෙලා තියෙන කෙනා මෙයා කියලා ගන්න. මොකද මෙයාගේ උඩ වගේ පෙවුනට නෙමෙයි වෙන්නත් පුළුවන්. මගේ සැක කෙනා කවුද? I take like main scale reading as 8. බලමු එතකොට 8 MSR is 8 millimeter. Vernier scale. Okay, මම දැන් මෙතන චෙක් කරන්න ඕනේ අන්තිම කොනේනේ 8 9 10 චෙක් කරන්න ඕනේ. 8 නෑ 9 නෑ පොඩ්ඩක් පැනලා 10 හරියටම සෙට්. ඒ කියන්නේ මෙයා 9 තමයි. Vernier scale reading is what? 10. Let me explain you. Eight millimeter plus 10 times 0.1. අනේ ලස්සනට එනවා 8 plus 1 millimeter, so 9 millimeter ම තමයි. එතනින් හොයලා ගන්න ඕනේ කියලා. 0.9 centimeter. හරි. ගමු දිගටම reading ටික දාගෙන. Only the zero line gone pass. Only the මේ error එහෙම හොයද්දි මේ වගේ තමයි ගන්න. Error calculation එකේදී zero error. It is almost like this. What is the main scale reading? මොකද මේ මෙයාගේ බිඳුව පහු කරලා තියෙන්නේ බිඳුව විතරයි. first line එකවත් පහු කරලා. zero. Let's try the Vernier scale. මෙතන බලද්ද මැද පන්නලා දෙන්න මේ හැට පේනවනේ පොට්ට ළමයි නෙමෙයි. මැද පන්නලානේ. මැද පන්නලා නම් හොයන්න ඕනේ 6 7 8 වගේ. This is 5 6 no 7 yes. හරි ලේසි මේ මන්ත්‍රයේ දෙන්න. Vernier scale is what? 7. So what is my reading is going to be? Main scale plus Vernier scale 0 plus 7 times 0.1 is like what? 0.7 millimeter. So 0.07 centimeter. Oh yeah, now a big one. 1 centimeter is almost gone. You can see it is obviously something below that. That means 19. Let's get the answer in millimeters. No harm. 5 centimeters වලට convert කරන්න. ඒක තමයි හොඳම විදිය මට මතක. ඕනනම් centimeters වලින් ගන්න ආසයි නම් කොහොමද දන්නවද? එතකොට මෙන්න මෙතනදී පොට්ටක් කොම්පින් යනවා. අමතක වෙලා දෙක පටල ගන්න එක තියෙනවා. ඒක නිසා millimeters වලින් අරන් අන්තිම එක centimeters කරන්න. Otherwise, you will apply that in 2 different units. One in centimeter, other one is millimeters. Then horrible class. So better is 2 centimeter means 20 නේ එක convert කරගන්න බැරි කමක් නැහැ නේ ළමෙක්ට. අපි අඩි කියන්නේ 90. centimeter වලින් ගත්තොත් කොහමද? centimeter reading 1.9 centimeter. Millimeter reading is what? 19 millimeter. I would like to take any of these. The main scale is 19 millimeter for me. ඔයාලා කැමති විදිහකට යන්න. මම අරගෙන අන්තිමට කන්වර්ට් කරන එක තමයි අපි කන්වර්ට් නොකර දාන්නත් එපා වැඩේ අවුල්. Now you may see this one has gone very far in. That means you have to check like 8 to 9 range. 8න් පටන් ගන්නවා 8 නෑ 8 නෑ 9 set. It is like the 9th. Vernier line is what? Vernier reading is N. N is what? 9. Okay, let's get the reading now. Main scale plus vernier scale is what? 19 millimeter plus 0.1 times 9. So it is like 19.9 millimeters. So your finalized answer is like 0.1, sorry, 1.99 centimeter. Put that 1.99. හරි මම හිතනවා බීරෝ ගන්න කියලා දෙන්න ඕනේ නැහැයි කියන එක. කමක් නැහැ මම තව එකක් කියලා දෙන්නම්. ඒ ඇති එතනින් නවත්තනවා. What is the line tallying? This is like the 15th line. See? 15. ආයිත් ඒක ගණන් කරන්න ඕනේ නැහැ. ඉතින් පහින් පහට මේකේ මාක් කරලා තියෙනවා. 1 2 3 4 කොටයි 5 උසයි. ආයිත් එක උසයි කොට 5 වෙද්දී අනිට පොඩ්ඩක් මැදින් උසයි. ඕවා ඇහැට කුරු කරගන්න. නැත්නම් ඉතින් පවුණන් ඉතින් 11 12 13 14 15 කියලා නිකන් බබා වගේ ගන්න ගමක් නැහැ. ඉතින් ආසයි මොනා කරන්නේ? What is my vernier? මේක නිකන් පටන් ගත්ත හරිය නේද? ඒ කියන්නේ පොඩ්ඩක් චුට්ටයි ඉහිලා තියෙනවා. බලන්නකො මේ 0 sorry ඒක 15 නේ. ඒක 16. හරි නේද මේ හරියන්නේ? එහෙනම් මේ හරිය වගේ. That means you have to check like 2 to 4 lines. First line, no. Second line is no. But the third line is exactly yes. අනේ අර මාර හැම එකකින් මේකෙන් ඉස්ලා බැලුවොත් කරුමනේ. මෙන්න මෙහෙම ගන්න. හරි ලේසි. Third. Right. Main scale plus vernier scale. 15 millimeter plus 3 times 0.1. 15.3 millimeter in terms of centimeter 1.53. හරි මීට වඩා නම් එකක්වත් කියලා දෙන්නේ නැහැ මේ ඇති. හරි ඉකින් එක රිපීට් කර කර බලන්න තේරෙයි. You just may need to repeat the stuff and wash it. ඇති. I conclude that it is enough for the reading purpose only. Let's go for the zero error and finalize. Now I am going to teach you the zero error and wind up with today's class. What is zero error? Zero error is defined as the condition in as the condition in which the measuring device registered the reading when there should not be any reading. Can you remember? I hold the reading. My height thingy in the video, I showed you like if I added up with some height, like 9 centimeters, it's not my actual height. If my height being cut off by 9 centimeters, that's not my height either. So I need to get my actual height. If there is any reading before, I want to take the reading. That is an error. That's what you say. Right? Zero error is that. Zero error in Vernier calipers and adjustment technique. Zero error are one of the most commonly occurring error in measuring instruments such as Vernier calipers. A Vernier caliper is a zero error when the Vernier caliper is set to close position. But measuring jaws are contact with each other, but the zero of the Vernier scale does not match with the zero error of the main scale. So the vernier is not zero. The zero error can be occur due to improper vernier calibration or as a result of mechanical shock, misdistribution alignment of the jaws, or wearing of the jaw. ඒකත් මතක තියාගන්න මේකෙන් කරලා නැහැ. Wearing off, ඒ කියන්නේ ගෙවිලා, or adding some grease or any what substance to the jaws. jaw එකේ පොඩි ගම් එකක් මොනවා හරි ඇවිලිලා නම් පොඩ්ඩක් වැඩිපුර වෙන්න ඉන්න කියන්න පුළුවන්. ගෙවිලා වැඩි නම් අස්සට යන්න. Like that. Okay, I think you understand what I'm talking about here. The biggest thing right now is I want to give you the definition for just the write that common definition for write that common definition. First point you have to write after the this thing zero error of Vernier caliper put that topic. Under that you have to write zero error subtopic zero error for any universal zero. What is that? The condition in which measuring device register a reading when there should not be any reading. Pause करने के बाद यार अभी video pause करना. Okay, now zero error in Vernier caliper කියලා आपको पारा clear. Zero error කියලා commonly අහුවොත් කලින් එක Vernier caliper කියලා අහුවොත් මම දැන් කියන්නේ. Right? When a Vernier caliper register a reading, while the jaws are tightly closed, without coinciding zero line of the main scale and zero line of Vernier scale. මට ආයිත් රිපීට් කරන්න කියන්න ඕනේ නැහැ. ඔයාම වීඩියෝ එක රිපීට් කරලා හන්ද ඒක අමාරුයි වගේ නම් මම හරි පොඩ්ඩක් බලන්න. චුට්ටක් ඒක රිපීට් කරලා ගන්න මානක දෙයක්. Zero error can be two times, either positive or negative, but no zero error have to be considered as well. When the zero line, no zero error means zero line on the Vernier scale is exactly coincide with the zero line of the main scale. There is no zero error condition. The positive zero error. What is the positive zero error? Now I'm going to read it for you. Positive zero error is when the zero mark on the Vernier scale lies ahead of the zero mark of the main scale of the class position. Now write the next subtopic. Next subtopic is what? Positive zero error. This is what the definition never get repeating. These ones are going to get asked in your exam. So better to know this, please. Pause your video and write this exact sentence like that. Okay, I gave you pausing time even. Now, write that. I don't want to read that again. The reading is greater than zero or positive. Very well. For example, the reading is 0.1 millimeter, then it is said that the caliper was like with the error of 0.1 millimeter. After 0.1 for 0.1 මොකක්ද sir කියලා ගියයි. නෑ in higher advanced technical application, if you can error of 0.1 millimeter, that's a massive error. What example එකක් කියන්න shall I tell you one simple example? You know there is a thing called engine in a vehicle. In the engine there is a thing called cylinders, right? In mostly cylinders and pistons. We call them like cylinder sleeves. Actually, the body sleeve එකක් බස්සලා තියෙනවා. Sleeves. This sleeve should be very smooth. These works are done in like things called what? Called lathe machine shops. ලියවන පට්ටල් කියලා like that. In there, they grind the thing. They use the Vernier caliper constantly and check whether the thing is exactly fitting with the size of the piston. So sleeve ගහනවා කියලා කරනවා. bore කරනවා කියන්නේ engine. bore කරනවා කියන්නේ අලුත් piston එකකුයි අලුත් sleeve එකකුයි දාලා කපනවා. නැත්නම් අලුත් piston එකක් විතරක් දාලා sleeve එක ගන්නට කපලා දෙනවා. දෙක ගන්නට දෙන්න. හරියටම 0.1 මිලිමීටර් විතරවත් වැඩේ අවුල් ගියොත් පුතේ මතක තියාගන්න දෙයියන්ගේ පිහිටයි. එකින් එක ආපහු බෝඩ් කරන්න වෙනවා. තෙල් ගහලා පිස්සුවක් වෙනවා කියන්නේ 0.1 කියන්නේ විනාශයක් තමයි. තේරෙනවද? 0.1 කියන එකේ පව accuracy එක තියෙනවා. Right? Okay. If you have zero error, you have to remove the zero. To eliminate positive zero error, the zero error should be subtracted from the total reading. Can you remember? If I took the reading on standing on certain brick like that, ගලක් උඩ හිටන් ගත්තනම් මෙයාගේ breaks නම් මන්තුනේ actual reading is what? Reading minus error. Can you remember? Subtract. I show you with proper example. For an example, total reading of 3.656 centimeter, the error is 0.05. Then the actual reading is what? 3.51. The actual reading is what? 3.56 minus 0.05. Then your answer is 3.5. And 5 here. Okay, very simple. You know, the magic net. There's no such magic in there. It's so simple. Negative zero error. Now I'm presenting negative zero error. Similarly, negative zero error is when you make a definition letter. Negative zero error is what? When zero error mark on vernier scale lies before the zero error mark on the scale when the caliper is closed. When the දෙන්නව වහලා තියෙන්නේ පොඩ්ඩක් මේ පැත්තට ඉස්සරහට පැනලා නම් ඉස්සන්නේ. Right? The other words of the zero error is less than zero. Negative error can be taken by adding the value of the error to the total reading. If you are on here, now the reading is here, scale 0 is beginning with here, and we will do some reading. Your actual reading should be this one with the error. So what is your error? Actual reading equals to reading plus error. So you have to definitely add that. Understand? So have a good look at here. There is an error. Let me get the reading here. Because roughly the reading is first, second, third. Our third line is coinciding. What is the error here? So if I take the error, least count multiplied by number of lines. I could very sorry. Under the positive zero error is I should have given you the error equation n times least count only. N times least count only. I forgot to give you. Please add this to your result. Here, this one has a good example from. You have to draw this line as well. Is an example. According to the example. According to example. Positive is what? Third line times 0.01. It is like just a reading. Just like taking the median of the reading. What is it? 0.03 millimeter is the error of this diagonal. Now let's come back to also. Negative zero error. Now let's try. I should have given you the negative zero error equation. It is different. Negative zero. If number of lines coincided in vernier scale, number of lines coincided in the vernier scale is simple n. And if total what? Number of lines in vernier scale is capital N. This is like a peculiar equation. Your zero error should be negative zero error. Its calculation is different from positive zero error. n minus simple n times least count. හරි නේද? මොකද මේක අනිත් පැත්තට යන එකක් නිසා මම ඔයාලට කලින් අර ඩයග්‍රෑම් එකට ගිහිල්ලා ඔක පෙන්නනවා. Okay. When it is moving forward, you can get මම මේක නවත්තනවා දැන් මොකේ කැමති දැනකින් නවත්තනවා. බලමු කොහෙන් වගේද සෙට් වෙලා තියෙන්නේ කියලා. It is more than 5 middle points, so you have to check like 7, 8, 9. 7, 6, no, 7 is somewhere, so approximately 7th line I can take. Yes. N equals to 7. That is my reading as well. 7 times 0.1, 0.7. Yes. But negative එකේදී මොකද වෙන්නේ? The negative zero error this runs to here. I am only moving very small distance. Very small distance. Which line you expect to be now coinciding? See, which line you expect? 0, 1, 2, 3, 5, 6, 7, and 8. Oh my god, 8 line. මම යව්වේ හෙන චුට්ටයි. වාට නිකන් ඇහැට තේරෙනවා මේ පැත්තට ලයින් එකක් නැන්දා. මේ පැත්තට ලයින් නැහැ නේ ළමයි. එතන තියෙන ලොකුම ප්‍රශ්නේ. නෙගටිව් ලයින් මාක් කරලා නැහැ. පොසිටිව් ලයින්ස් ටික විතරයි. In the main scale. If you draw a line, if it is to be 0.8, it should come to here. එන මේ හරියට එන්න ඕනේ. එහෙම ගිහිල්ලා නැහැ නේ ළමයි. එහෙනම් පොඩි දුරක් නේ ගිහිල්ලා තියෙන්නේ. පොඩි දුරකට අටක් වෙන එක අසාධාරණයි නේ. එහෙනම් අපිට තේරෙන්න ඕනේ by extend and enlarge this one. If I enlarge this one and I can show you, it has gone somewhere like what? 0.2 වගේ තමයි ගිහිල්ලා තියෙන්නේ. හැබැයි 0.8 පෙන්නනවා. වැඩි අවුල්නේ. එහෙනම් රින් එක ගන්න මම මොකද කරන්න ඕනේ? Total number of line වලින් subtract කරන්න ඕනේ. Because that means if I want to take the actual error reading, actual number which is coinciding, it should be definitely, obviously smaller than 8. So how to find out? There are total lines of 10. This is what called capital N. It is 10. This is what called the simple N. Is 8. So the actual reading is now is what? Reading now is 10 minus 8. එහෙම නේද? මම හිතනවා ඔන්න අයිඩියා එක ඔළුවට යන්න ඇති කියලා. තේරෙන්නේ නැත්නම් ඉතින් අර ස්පේෂල් රෙකග්නිෂන් එකේ පොඩි අඩුවක් තියෙනවා. කාඩ්බෝඩ් එකේ ඔය වගේ එකක් ඇඳලා ස්ලයිඩ් කරලා බලන්න. ඊට වඩා ඉතින් මට උදව් කරන්න තේරෙන්නේ. හරි. Let me get this reading now for you. So it has only gone if you draw a exact line like this. ඔයා හිතලා බලන්න මේ වගේ line එකක් ඇඳලා නම් තිබුණා නම් කියලා හිතලා. pencil එකකින් ඇඳගත්තට කිසි පාඩුවක් නැහැ. MCQ එකක් නෙන්නේ. Draw a line, extend this apparent line නම් point 2 මම මේ වගේ එකක් check කරන්නේ දෙකේ ඉඳන් 4 වගේ මතක තියාගන්න මම කන පිටනේ. දෙක කියන්නේ 8. ඒ කියන්නේ එහෙනම් ඔයා check කරන්න ඕනේ 6 ඉඳන් 8 වගේ. 1, 2, 3, 4, 5, 6, 7, 9, 8. 8 is there. 8th line is the one coincide. හරියටම 8 වෙනි එකනේ coincide වෙන්නේ. So that is not my reading at all. That is not my reading. Vernier scale reading is what? 10 minus 8. Remember that? 10 minus 8. So what is my error is going to be? Negative error is 10 minus 8 times 0.1. It is like 0.8. Sorry, 0.2 millimeter. Oh, my කතන්දරේ තේරුම් නැත්නම් මම රිපීට් කරලා බලන්න. මගෙන් personally අහන්න. Call me and ask me personally. No problem. Now I'm solving that thing again. හොද පණි දානවා වගේ පාරක් තියෙන්නේ මේක කතන්දර ළමයින්ට උඩට යනවා හරියට දන්නවනේ. මමත් A level කරානේ. හරි. Only 9. 0 and 0 contact, no 0 error. 0 and 0 not contact. It has gone forward. The 8th line is coinciding. There is a positive error of 0. Now see, it has gone so far. Which line and which line coinciding? The 4th line is coinciding. That means what? Why it is 0.8? 8th line how to get it? 10 minus, sorry, 6. 4 times 0. 0 what? 0.1 centimeter. This is given in centimeter. No? So what is it? 6 times 0.01 is times 0.06 centimeter. හරි නේද? ඔක පටල ගන්න නැති වෙන්නයි මම කියන්නේ මිලිමීටර්ස් වලින් හොයලා අන්තිමට කන්වර්ට් කරන්න කියලා කී වරදක් නෑ. ආපහු පාරක් දෙන්නකො. There can be 0 error on your instrument. Always check. No 0 error. See, read that. The lines for the 0 are aligned. The 10th line of the lower scale line up with the 9th line of the upper scale. Okay. Positive reading 0.094 millimeter here. The line up with upper scale. Upper scale එකේ ඕන කෙනෙක්. Upper scale එකේ කවුද කියන එක ගන්න දෙයක් නැහැ. So 0.04 millimeter needs to be reduced from any reading you taken. Negative reading are the 7th line up with the upper scale because the jaws are out by 0.03. මං කියන්නේ 7 ගියාට 10න් 7ක් අඩු කරලානේ ගන්න. එතකොට තමයි එන්නේ. Before need to be added to the reading taken with the instrument. I explained more than you want. Now find out the reading of the calipers below. Hurry. මේක තියෙනවා මරු ඒවා දෙක. එකක් ගන්නම්. Only take one. Third. Oh, this is, remember that this is centimeter scale. 3 centimeter කියන්නේ millimeters වලින් ගත්තොත් 30 නේ. 29 back out back. 29, 28, 27, 26. මතක තියාගන්න main scale is what? 27. අපි අපව ගමු 28, 29. No, wait. 26. 27, 28, 29, 30. හරිනේ. ආපහු count කරලා ගන්න. You have to consider this like 30, 29, 28, 27, 26. Because I like millimeter and finally convert. Right. Then the scale is what? 26. What is the scale? It should be first few lines. දෙවෙනි line එකම ගන්න section on experience. Vernier scale is what? 2. So what is Vernier reading? 2 times 0.1, 0.2. So you have to add that 26.2 millimeter. Or in centimeters, 2.62 centimeter. පස්සේ convert කරන්න. මම නම් කැමති එහෙම. හරි නේද? මෙතන නම් 0 වලින් පටන් අරන් තියෙන එක ලොකු අවුලක් නැහැ. Now again, I told you, when you see any number, ඒ number එක trace කරගෙන යන්න. So this is 14. What is this going to be? 39, 38. අනිත් පැත්තට calculate කරන්න. This is 38. Not with the 0. So you should check very first few lines. Third line 38.3. දැන් අහන්න එපා 0.3 කොහමද ආවේ කියලා කනට ගන්න. Here 6 දැක්ක ගමන් 60 කියලා ගන්න. ආපස්සට 59, 58, 57, 56. මම නම් එහෙම ගන්නෙ නෑ. මෙතන ගෙලින්ම 55 කියලා ගන්නවා. පහක් අඩු කරපුවම 55, 54, 53. ඒවා හැට පේන්න ඕනේ. මෙතන පහේ line එක උසයි. You have to understand the fifth line is taller. Then you can exactly count 5 from here. 55, 53, 4, 53. This is like 53 point. Let's get the reading. Which line? Be closer. First line, 53.1 millimeter. Hurry lazy. Assuming that the jaws of the caliper are tightly closed. What the heck? Tightly closed. Find the 0 error of the vernier calipers below. Positive and number 1, negative. පටන් ගද්දිම ගාවන්කෝ කියලා නෙගටිව් එකක් තියලා තියෙනවා. වමට මේ ගිහිල්ලා තියෙන්නේ. වම නෙගටිව් දකුණ පොසිටිව්. ටිකක් ඈතට ගිහිල්ලා වැඩිනේ. බලන්න කීවෙනි ලයින් එකද සෙට් වෙලා තියෙන්නේ. 4 වෙනි ලයින් එක සෙට්. Fourth line is matching. Fourth line matching means it is not the fourth line. හොඳට මතක තියාගන්න. නෙගටිව් වලදී මම කිව්වා ගන්න විදිය හරි වෙනස්. In negative error, what is it? 10 minus 4 times 0.1, 6 times 0.1, that is like 0.6 millimeter is my negative error. Or error equals to negative 0.6 millimeter. But negative error equals to 0.6 millimeter. Put that negative sign here mathematically. Do it. If x equals to minus 5, y equals to minus 6. That's it. Okay, here it is a positive error, definitely. So you can assume that it should be more than 5. So check after 5. Exactly on 6th line. So what is it? Positive error equals to 6 times 0.1, exactly 0.6 millimeter. Hurry. මේ බලන්න මෙයාගේ හරියටම 10 උඩ සෙට් වෙනවනේ like බල ඉන්න බා මෙයාගේ බිඳුවයි 10යි 10ට සෙට් වෙනවා කියන්නේ ඊළඟට පැනලා හරියට. It's like 1 millimeter. Error equals to 1 millimeter. හරියටම පැනලානේ. හරියටම පැනන ගමන් ආයෙත් හිතන්න එපා 10ට සෙට් වෙනවද කියලා බලන්න. 10ට සෙට් වෙනවා නම් හරි එකයි. බිඳුවම යා වගේම පේනවා. සමහරක් විට මෙතන 10ට ලැබුණා. මේක සෙට් වෙලා නම් 0.9 නා 10ටම සෙට් වෙලා නම් හරියටම මිලිමීටර එකක් පන්න. එකයි. මේ ඇති. ඒ දේවල් ටික ඇති. හරි. දැන් ඔයාලා දන්නවා ඒක රීඩ් කරන විදිය නේ. අපි යමු බලන්න ටියුට් එකට previous zero error. This one is there already. Worked examples are there. Okay. I explained this thing. This thing in that class, the circular Vernier scale thingy. Video is getting too long, then I will get rid of this one exactly and explain you. But I'll be done among us and any video call about this. There's a thing called circular Vernier scale. In the last class, I gave you a note even, but under like hazardous condition. Extremely not necessary, yeah. Video light thingy can never tackle the no need. Surveyor guys are using this thing, right? Right, the circular Vernier scale and degree scale. You can just get it to degree scale. This one you need spectrometer thingy. මගේ අර තිබුණ කැත spectrometer එකක් මේ අලුත් එක. The main scale is marked in 0.5 degrees. What? 0.5 degrees. Okay. Vernier scale reading. Let's see. Spectrometer need to. Spectrometer scale to know. Need to know. Megaphone. The circular scale is divided into what? 30 divisions, which coincide with the 29 of main scale division. X times 29 divide කරනවා කැලි 30කට. ඔක තමයි least count of what? Vernier. Circular Vernier. Circular Vernier is what? X times. Let's see what is X. If the main scale division is 0.5. So what is that X? Half into 29 over 30 is my least count of the Verniers. Least count. The least count of the Vernier scale only, least count of the vernier is 1 main scale division minus 1 vernier scale division. Oh yeah. Okay, 1 main vernier scale division is what? 29 parts divided into 30 of the main scale division. 1 main scale minus 29 over 30. Main scale is what? 1 over 30 main scale division. Now you know what is main scale division. Half. Half times what? 1 over 30 is 1 over 60. Least what? Least count of the vernier scale. You know that least count of the main scale minus vernier scale. Isn't that? Least count of the vernier scale minus least count of the now we look at main scale is what? Half degree minus vernier scale what? Half degree times 29 over 30. I will leave it like this. So here it's going to be half minus 29 over 60. So if I cross multiply, this becomes 30 minus 29 over 60. So if I get to common denominator here, 60 equals to 30 minus 29. So it is like 1 over 60 degree. That is equals to 1 minute. මේ මිනිත් සිස්ටම් එක O level වලදී අහු වෙලා නැත්නම් මට කියන්න අපහු කියලා දෙන්නම් O level කතන්දරයක් equation මේ. Now you can apply this to the same equation we learned in the last week. Can you remember? This thing you can apply to here. Let's see. Half equals to 1 minus 29 over 30. So what is it? Half by 30 minus 29 over 30. This again half by 1 over 30. So your answer is 1 over 60 degree or 1 minute. Again. So this is really important phenomena, really important scenario to know, because in the term test you will definitely get this type of question. Okay. Now we have made many such measurements and work examples. Lamai, there are many worked examples there, and I want to teach you like the extended vernier caliper now. පොඩ්ඩක් එන්නම් extended කතන්දරයට. I am going to teach you the extended vernier caliper. I have already given you an implication of that in doing some questions here. We were discussing extended කියන්නේ ඇයි කියලාත් මම කිව්වා. So these ones are extended ones. These all are extended. Only this thing is the standard one. This thing is exactly like the caliper I provided to you. This is the one you may get in your school mostly. So this one is rare to find. It is not actually in use. It's theoretical one. That's why I told you to try to find it. I will tell you extended mean පොඩ්ඩක් ඒ කතන්දරේ තව accuracy එක වැඩි කරගන්න. In the things like what is it I called කවුද මම අර කිව්වේ those guys in lathe machines 1 2 3 4 5 7 8 9 10 11 12 13 14 15 16 17 18 19 and 20. Okay. Now for normally 19 parts of the main scale is divided into how many parts? And then the 20. Okay, first type of extended vernier caliper. Extended. Extended means I'm not going to give you any note. They will never ask. Extended vernier caliper means what? To get more accuracy, the vernier scale can be extended with higher number of parts of the main scale divided with one more part. 9කට 10 එකත් ඒක නැතුව 49කට 50 very accurate but hard to read. Okay, this is the first type of extended vernier caliper. What is the least count of the vernier scale here? Let's see what is the least count of the vernier scale here. 19 millimeter over 20. So what is it? 19 over 20 millimeter or 0.95 millimeter. Right. Least count of main scale is what? 1 millimeter. So least count of vernier caliper is what? Main scale minus vernier scale. So what is main scale? 1 millimeter minus 0.95. So your answer is like 0.05 millimeter. I am getting this answer for the second time for today. හරිද? සමහර ඒවා ඕක තව පහකට විතර කඩලා දානතර 49යි 50යි 99යි 1යි මම ඔයාලට කිව්වා ගෙදර යනදලා බලන්න කියලා. ඒක තමයි extended vernier caliper කියනයි කියලා දෙන්නේ නැහැ. So this is what the extended vernier caliper. I explain you this phenomena using that tall guy and low short guy thingy. Just tell this scenario and try to understand. Great. There are many worked examples. Some of those are really hard to understand. No need to know, but it will increase your capacity of understanding likes of these questions. You may try. There are some facts were given. Hard questions. This is something the standard one. Hard to easy. Everything is there. And degrees will be the piano. If you practice these work examples yourself somehow, no vernier question will trigger you. I assure you with that. So let's go for the term test paper question and finish the session. Term test paper question. Oh yeah. The figure show metal piece made of same solid material. It consists of 3 coaxial cylinders. Again, coaxial කියන්නේ හරියටම center to center set වෙන්න set කරලා තියෙනවා. මෙයාගේ center එකයි මෙයාගේ center එකයි coaxial එක. coaxial කියන්නේ ඒක. වචනාමයින්ට තේරෙන්නේ නැහැ. coaxial cylinders. Diameters, heights, and are given and shown in the figure given below. Approximately values of measurements given as V1. V1 is, yes. Yeah, this is D1. 4 centimeter here. D2, 1 centimeter. H1 here, 1 centimeter. H2 here, sorry. H2 here, 2 centimeter gap. You are provided vernier caliper to determine the volume of metal piece so that the vernier ruler is not convenient to obtain above length measuring using a suitable calculation. Why? Because vernier caliper is about to use our regular vernier caliper is in the range of what is the minimum reading you can obtain? Minimum reading. minimum reading. So for regular vernier caliper, what is the least count of the vernier caliper? Least count of the vernier caliper is what? 0.1 millimeter. So I told you the percentage error equation is what? Percentage error equals to least count over reading times minimum reading now 100%. I told you the percentage error can maximally occur 1%. So here it is what 1% equals to the least count of what 0.1 millimeter divide by the reading, minimum reading I don't know, by 100%. So the minimum reading is like 10 millimeter or 1 centimeter. So you can use this to above 1 centimeter. If you have to get any reading beyond 1 centimeter, you have 10 centimeter. You have what? Meter ruler. If you want something extremely accurate, like what I said, like engine boring, you have to use the vernier caliper, longer vernier calipers. But like regular things, you can take up to the reading of 1 centimeter to 10 centimeter. I taught you this thing in the very last week. If you only don't remember, have a look at and try to understand that back. So because why? Because there are what? Smaller readings like 1 centimeter. 1 centimeter තිබුණාට exactly 1 centimeter ගන්න බෑ. හරි. 1 centimeter වලට වඩා ලොකු කියලානේ කියන්නේ. වඩා කියන්නේ පොඩ්ඩක් හරි වැඩි වෙන්න ඕනේ 1.1 වත් වෙන්න. It is useless. So there is a device called what? Micrometer screw gauge. You can measure up to 1 millimeter to 1 centimeter. ඒකට micrometer screw gauge එකක් තමයි හරියන්නේ. Which part of the vernier caliper would use to which part of the vernier caliper would use to measurements H2, H1 and H3? H1, what can you use? External jaws. මෙන්න මේ jaw දෙක මෙන්න මේ විදිහට set කරන්නේ. External jaws. Diameter also external jaw. You hold the external jaw. But here in this one, you can't use the external jaws. You use what? Internal jaws. There is another thing called step measuring. Step measuring is not for A level. So this part H2 is for H1 is H1 and D1 and D2. Both H1 apart from H2, external, internal, external, external. How could you check the zero error of the vernier caliper? How? By what? Closing caliper and see whether there is any reading on the caliper. Caliper එකේ reading එකක් වැරදිලා හරි තියෙනවද කියලා බලන්න. Number 2, if the least count of the main scale of the caliper is 0.5 millimeter and the instrument has 25 vernier divisions. Oh yeah. So that the least count of the vernier caliper is like this much. Okay. What is the least count of the vernier scale? Vernier scale only 0.5 over 25. එහෙමත් ගන්න පුළුවන් නම් least count of caliper, vernier caliper can be taken like what? Least count of the main scale divided by number of lines. So what is the least count? 0.5 over 25. In our regular one, what is it? 1 millimeter. 1 millimeter එකක්නේ කැලි 10කට බෙදලා තියෙන්නේ. එකක් හිතාගන්න. millimeter එකක් කැලි 10කට බෙදුවා වගේ තමයි. Then it is again 0.1 millimeter. So you can get it directly. Vernier caliper. What is the least count? You divide that into 50 parts. That's the other meaning. What is it? 5 over, sorry, 1 over 50. So you can get it like 2 over 100 as a equivalent fractions. 0.02. අතවසරේ maths උත් ඕන වෙනවනේ. Equivalent fractions, get it to equivalent fraction. මෙන්න මේ විදිහට ගන්නත් පුළුවන්. මට ඒක කියන්න අමතක වුණාද මන්දා. මම මේ recording එකක් නේ කරන්නේ ළමයි. There is another method to get the least count of the vernier caliper. Vernier caliper least count is what? Least count of main scale divided by number of divisions in vernier scale. හරි මේක ඕන කරන equation එකක් least count of vernier caliper equals to least count of main scale divided by n of vernier scale. පත් පැත්තකින් ලියා ගන්න මෙහෙමත් ගන්න පුළුවන්. හරි නේද? අපි අර කලින් අරගත්ත extensity එකට දාලා බලමු. අපිට මතකද 19 to 20 ratio. 19 millimeter to 20. Here what is it? The least count of the main scale 1 millimeter. So what is the number of lines? 20. It is like what? 0.05 millimeter. The second extended one I found is what? 49 to 50 degree. 1 millimeter divided by what? 29. Sorry, 50. So it is like what? 2 over 100, 0.02. Again, we got a weird one. 99 to 100. But 1 millimeter over 100. So what is it? 0.01 millimeter. මේක හරි ලේසි. ඒ වුණාට මම මේකට ආස නැහැ කියලා දෙන්න ළමයි මොකද හොරපාරින් යන්න කියලා කොයි විදිහට යන ගන්න. හරි ලේසි හොරපාර. right. අරකටත් ගන්න පුළුවන්. මතකද මම අර කියලා දුන්න කතන්දරේ අර circular scale 29 parts divided to 30 parts. What is the least count? Half. How many parts? N equals to 30. Let's see. Least count of spectrometer. What is it? Half degree divided by 30. So what is it? 2 times 30. So that means 1 over 60 degree for 1 minute. මේක තන්දරේ හරි ලේසි. මම ආස නැහැ ඔබ කියලා දෙන්න. කමක් නැහැ. Sometimes you may need that one as well. ඒක ලේසි වැඩි. ලේසි එක කියලා දුන්නාම ඔයාලා concept එක ඔලුවට ගන්න මහන්සි වෙන්නේ නැහැ ළමයි. ඒක හරි භයානකයි. මම ඒක ලේසි එක අන්තිමටම කියලා දෙන්නේ. ළමයි කැඩෙන්න ඉඩ තියෙනවා. කමක් නැහැ. ඉන්න උන් ටික හරියට ඉගෙනගෙන ඉන්න. මොකද ළමයි රඳව ගන්න ආසි ඊසි දේවල් ටික කර කර හිටියොත් hard MCQ එකක් ආපු ගමන් ඔයාලා ඉවරයි. හිතලා කරන්න පැත්ත මුලින්ම පුරුදු කරලා ලේසි දේ පස්සේ කියලා දෙන්න. ලේසි දේ කියලා දුන්නොත් පුතේ ඔයාලා හිතලා කරන පැත්ත හිතන්නේවත් නැහැ. මම දන්නවනේ ඔයාලගේ ඇටි. Okay. The relative position of the main and vernier scale of the caliper used to determine measure D1, D2, H1, H are shown in the find the appropriate value for the given position. Caliper used has no zero error. My bird make a read for make a lesson name mage putte කියලා කියන්න. ඒක මාක් කරලා තියෙනවා. එයාලා හොඳයි. එයාලා හරි හොඳ මිනිස්. They have marked it. හරි හොඳ ළමයි මේ එයාලා. So what is it? 40 මේකත් මාක් කරලා තියෙනවා. 41.5. A main scale reading is what? 41.5. මට මෙහෙම කරන්න පුළුවන් වුණාට ඔයාලට එන පොතේ ඔක එන්ලාජ් කරලා බලන්න බෑ. හරි කරදරයි. ටර්ම් ටෙස්ට් වල මේ වගේ අපහැදිලි රූප දෙනවා. මේක ටර්ම් ටෙස්ට් එකක් නේ. This is the second line. මතක තියාගන්න එක ලයින් එකක් කැල් කීයකට බෙදලා දෙන්න. පහකට බෙදලා 1 2 3 4 5. This is not second. 6 7 8 9. Can Namek come is it? Partner me. But it's Namek gonna be up. Okay. What is the reading equals to? Main scale plus Vernier scale reading is like 41.5 millimeter. I like the millimeter, even though it is given in centimeters. What is my main scale reading? Vernier scale reading? Yeah, 9 times. What is the least count of this device? They say the least count. How many divisions are there? 50 such things. So 25 divisions name. අපි හොයාගත්තා නේද කීයද කියලා. 0.02 ඔයාලා ස්කූල් එකේ තියෙන්නේ මේ කැලිපර් එක. ඒක නිසා පාවිච්චි කරන්න පුළුවන්. ගොඩක් ස්කූල් වල මම දන්නේ ක්ලිප් එක වල කොහොමද වෙයිද කියලා. 0.18 right. ඇඩ් කරපුවාම කීයද එන්නේ? 41.68 millimeters. When you write that in centimeters, you can write it like what? 4.168 centimeters. Have they given? No, centimeters. Centimeter Indian. හරි නේද? අන්න මම එකක් කියලා දුන්නා. ඉතුරු ටිකත් ඔය වගේම තමයි. මම තව එකක් කියලා දෙන්නම් ඔයාලා පහුඩි. හරි. This is like coincide with the main line. අද තියාගන්න මේක 20 නේ. millimeter වලින් මම ගන්නේ 19, 18. Main scale is what? 18 millimeter. Vernier scale is to this line. අටයි. Vernier scale is what? Vernier scale is 8. 18.00 plus 8 times 0.02. 18.00 plus 0.16. It's like 18.16 millimeter. So in terms of centimeters, 1.816 centimeter. ඇති දැන් හොඳටම ඉතින් ගන්න write an expression for the volume of the metal sphere in terms of above symbols. Means මතක තියාගන්න ළමයි, it is a composite object. What is a composite object mean? තනි එකක් නෙමෙයි. So there are, this is like a dumbbell නේ. H1 H2 D2 D1 වන්න මට මතක තියෙන්නේ. It's something like this. Above 11. D1. D1, D2, H2, H2. හරි. එතකොට මේ එකක් ගන්න. I'm considering one dumbbell here. I will mark it like X. This one is also X. The middle one is Y. Vx is what? Y D1 over 2 square times H1. මේ වගේ ඒවා දෙකක් තියෙනවා. එතකොට ඒ කතන්දරේ ඉවරයි. Vx total is 2 times of that. Here the other one, Vy equals to, what is it? Pi d2 over 2 square times what? The height of h2. මෙන්න මේ දෙන්නගේ ඇඩ් එක. එතකොට මොකද වෙන්නේ? pi d2 over 2 square h2 plus pi d1 over 2 square h1 times 2. තමයි ලියන්න තියෙන්නේ. Write down the two readings that you would make to find the volume of metal piece if you were displacement method. Purpose meaning cylinder provided for you. ඔකේදී මොකක්ද ගන්නෙ? Volume. Initial reading of the measuring cylinder and the final reading of the measuring cylinder. I will explain you this phenomena in the very next week because I should perform that live as a live performance. නැත්නම් ඔක ඇත්තට ලොකුට තේරෙන එකක් නෑ. හරි. මම ඔක measuring cylinder එකට දාලාම කරලා පෙන්නන්නම්. මේක කිව්වට හරියන්නේ. මට නිකන් හරි මම අමතක වුණොත් ඔයාලා මතක් කරන්න ඕනේ. Let me see this one. බෑනේ කරදරයි නේ අද වැඩි. ඊළඟ දවසේ අපි question discussion එකකට දාද්දි මම මේ ටික කරන්න. අන්තිම පැය භාගෙදි question discussion එකක් යනවනේ. අන්න එතනදී live කියලා දෙන්න. හරි. නැත්තම් මට බෝරින් වෙනවා දැන්. ඔයාලා කරන්න බෑ. ඒක කරන්න පුළුවන්. හරි. බය වෙන්න එපා මේ වගේ මොනවා කල මට මේ අවුරුදු දැන් online class කරන්න නම් අවුරුදු 4ක් කොරෝනාත් එක්ක නේ කොරෝනා අවුරුදු 4 වෙනි අවුරුද්දේ නෑ. මේ අවුරුදු තුනට මම online පටන් ගත්තේ කොරෝනා වලට කලින් යුනිවර්සිටි එකේ ඉන්න කාලේ. So I started to do like those online classes for London students even before COVID. මට කවදාකවත් මේ වගේ නම් ලැග් එකක් ඇවිල්ලා නැහැ. වෙන්න පුළුවන් worst ම දේ 4 years 5 years history එකේ වෙච්ච පළවෙනි වතාව. එහෙම එකක් වුණත් මගේ ගාව solutions තියෙනවා. Okay ළමයි. God bless you. Bye.